write something down, let's just think about what we've done so far this year. Chapter 1 dealt with integers, order of operations, and their properties. Chapter 2 dealt with fractions, adding, subtracting, multiplying, dividing, again, both positive and negative numbers. And chapter 3 is going to be dealing with decimals. And it kind of makes sense that we're going here because fractions, decimals, and percents are common things that we see every day. So 3.1 is about comparing decimals. And look at their place value. And what that means is it's going to depend on the digit's position relative to the decimal point. So if I'm going to be looking at this 3, its place value depends on where this decimal point is. So it's going to be 3/10. The 2, again, relative to the decimal point, the place value for this 2 would be the hundredths place. So this decimal represents the score or the time for Bolt in one of the Olympic races. So we have to use decimals because when things are really, really close together, we have to have a way to say, okay, which one came first, which one came second. So you can see how these times right here for these runners were really super close. And then we'll talk a little bit more about this reaction time. I just thought it was kind of interesting to leave it here. But again, notice how close the numbers are. And this has nothing to do with who won. This would be who won the race. And then the PB stands for the personal best. Again, notice that all of these runners ran in 19 seconds, which is super fast. And the way I would say this decimal is 19 and 32 hundredths. And then this one would be 172 thousandths. So again, notice that TH at the end. So we'll go to this website after the video and you can see a little bit more about the reaction time. I'll also show you a website and some statistics on ESPN because again, when things are really close together, like when the batting averages are really close, we have to have a way to say, okay, which one has the better batting average? And we have to have a way that we can list them. So don't write anything down. Don't stress. I just want to take a look at this. I know it's a lot to look on at the slide. So let's take a look at where the decimal is. And we're going to be pretty close to using the numbers around here. Again, you're in 7th grade, so it's going to be both positive and negative decimals. So the tenths place, the hundredths, the thousandths, and over here we have our ones, our tens, our hundredths, our thousands, and all the way that's written is 100 billion. And this is a really big number. I wouldn't mind having a fraction of this in my bank account. So what I wanted to use this slide for is just for you guys to highlight how different it is in 20 years ago when I was in school. I wasn't thinking about billions. We were hearing things that were millions. And now you even hear things with the trillions. So it's kind of commonplace to hear billions and trillions, whereas 20 years ago, we didn't really hear those words. So I'll ask one of you to see if you can say that properly. And again, on this slide, calm down. You're not writing anything down. You're just looking at it and you're like, whoa, way too many words and numbers. So let's just take a look at a million. So a million has a 1, and then it has 1, 2, 3, 4, 5, 6. 6 zeros. A billion has 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So again, we have these fancy words, trillions. You will hear that, and I'll show you the website for the U.S. debt that will show it in trillions as well. But we really don't use these words. I just kind of wanted to show you. And then before I made this video, I did a search to say what was the largest word or word given to a number, and this is what I found. So this was kind of interesting. And it's basically what it's doing is just taking the one before it and saying, okay, well, it's going to be a 1 with a googolplex of zeros. So our googolplex is a 1 with a googol of zeros. A googol is a 1 with 100 zeros. So I just think it's kind of interesting. For your purposes, just know that numbers go into infinity, both the positive and negative direction. So let's talk about comparing decimals. So you do need to write this one down. So the first thing that we do is we look at the digits that are in the same place value. The second thing that we need to do is compare the digit closest to the decimal where the two numbers have different values. So let's take a look at this right here. I have a 3 and a 3. Then I'm going to look at the 2 and the 5. So if I want to look at this, I want to compare. So basically what you're going to be doing for this section is, let's get this down. You're going to be finding which is greater than, or less than, greater than, or equal. So here I know that they're not equal, but the 3 and the 3, and then the 2 and the 5 differ. So this is where you could think money, you could think just the lower number. Again, when it's the negative, though, you kind of have to think reverse. You're in 7th grade now, so you have to think a little harder. But this one right here would be less than. So remember, the alligator is hungry, so he's going to open up to the one that's bigger. Again, it's nice to look at this particular one in terms of money, because if you had $3.25, that would be less than $3.50. But sometimes money doesn't help. So let's look at this example. This would be compared with this one right here. So what I want to do is look at, again, I'm going to go in a 4 and a 4. A 2 and a 2, a 2 and a 2. Oh, I have a 1 and I have a 2. So which one would be less than? So now I'm comparing the digit where that's closest to the decimal, where the two numbers have the different value. So I have a 1 over here and I have a 2 over here. Yep, that's right. This one is going to be greater. So the alligator is going to open up that way. Now, you're kind of probably thinking, hey, I got this, it's okay, but you got to really be careful, especially when you get more than just a few digits, and especially when you have a negative in there. So if you don't, I guess, to me, this is the easiest. But one of the things you can do is, the second method, is just to graph the decimals on a number line. And the most important thing to remember is that wherever you put the ones furthest to the left is going to be less than. So this one's not going to be a very accurate number line as far as the increments, but let's just go ahead and put a 0 here, and then we have our negative, and then we have our positives. So I'm going to look at this one, 7/10, okay, and then I'm just looking around. Okay, so 7/10, let's put him right here. And then negative 1 3/10. So I know it's going to be to the negative. So I'm just going to put a negative over here. Negative 1.3. Now, this is where I'm going to get in kind of a little bit of trouble because I didn't space it out that right. But this is negative 4/10. So 4/10 would be somewhere in between here. I'm just going to put it. And then 1 5/10 would be somewhere out here. And we're used to just saying 1.5 or 1.5. And then this one over here, negative 9/10, is going to be somewhere over here. Okay. So remember, left is less. So this one would be the one that's the least amount. And then it would go this. Let me put that little negative back down there. And then it's going to go here. And then it's going to go here and here. So again, I know you're probably thinking, I got this is cool, but you got to really be careful, especially when the negative is, and take your time, space it out. Don't be afraid to write it down.